The neutral conductor in an electrical service must be sized to handle the maximum unbalanced load. This means the neutral conductor should be the same size as the ungrounded conductors. This requirement stems from the need to ensure the neutral can safely carry the largest possible current difference between the phases. Article 220.61 of the National Electrical Code, or NEC, provides guidance on determining the maximum unbalanced load for services. The maximum unbalanced load is defined as the maximum net calculated load between the neutral conductor and any one ungrounded conductor. In practice, this means you should calculate the load connected to each phase. Then determine the largest difference between any one phase and the neutral. This difference represents the maximum current the neutral might have to carry. Using a neutral conductor smaller than the ungrounded conductors can create a hazardous situation. If the unbalanced load exceeds the capacity of the neutral conductor, it can overheat, potentially leading to insulation damage or even a fire. In the specific scenario of selecting service entrance cable or SER, the cable must have a neutral conductor that is the same size as the ungrounded conductors to meet code requirements and ensure safety. Often, SER cable is available with a reduced neutral size, but this is not appropriate for service applications where the neutral must carry the full unbalanced load. Therefore, it is important to select SER cable where all the current carrying conductors, including the neutral, are of equal size. You are correct in your understanding that a smaller neutral conductor is generally not permitted for service applications. The code mandates that the neutral be capable of handling the maximum unbalanced load. This often leads to the requirement for the neutral to be the same size as the ungrounded conductors. When selecting a SER cable, ensure that all conductors, including the neutral, are of the same gauge. If you are unable to find a SER cable with all conductors of the same size, you may need to explore alternative wiring methods such as using individual conductors and conduit. Understanding the concept of unbalanced load is crucial for proper service sizing. An unbalanced load occurs when the current draw on each phase of a multi-wire system is not equal. This can happen due to a variety of factors, such as uneven distribution of single-phase loads or the presence of three-phase equipment. To calculate the unbalanced load, determine the current flowing through each phase. Then subtract the smallest phase current from the largest phase current. The result is the maximum amount of current the neutral conductor must be able to carry. It is important to consider future load additions when sizing the neutral conductor. If you anticipate adding more loads in the future, you should factor this into your calculations. Oversizing the neutral conductor slightly can provide a margin of safety and prevent the need for future upgrades. In summary, for service applications, the neutral conductor must be the same size as the ungrounded conductors. This is to ensure that the neutral can safely carry the maximum unbalanced load. When selecting SER cable, make sure that all conductors, including the neutral, are of equal gauge. If you are unsure about the proper sizing of the neutral conductor, consult with a qualified electrician. They can perform a load calculation and determine the appropriate conductor size for your specific application. Ignoring this requirement can lead to dangerous situations, including overheating and fire hazards. Always prioritize safety when working with electrical systems. In situations where the calculated neutral load is significantly less than the ungrounded conductors, there might be exceptions that would permit a smaller neutral. However, these exceptions are very specific and require careful calculations and adherence to the NEC. It is always best to err on the side of caution and use a neutral conductor that is the same size as the ungrounded conductors. Always consult the latest edition of the NEC and local codes for the most up-to-date requirements. Local codes may have additional requirements that are not covered in the NEC. Proper grounding and bonding are also essential for electrical safety. The grounding conductor provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. The bonding conductor connects all metallic parts of the electrical system together, creating a low impedance path for fault current. When working with electrical systems, always de-energize the circuit before beginning any work. Use a voltage tester to verify that the circuit is de-energized. Wear appropriate personal protective equipment, or PPE, such as safety glasses and gloves. Never work on electrical systems when you are tired or distracted. If you are not comfortable working with electricity, hire a qualified electrician. Electricity can be dangerous, and it is important to take all necessary precautions to prevent injury or death. In addition to the NEC, there are other resources available to help you learn more about electrical safety. The Electrical Safety Foundation International, or SV, is a non-profit organization that provides educational materials and resources on electrical safety. The National Fire Protection Association, or NFPA, also offers training and certification programs for electricians and other electrical professionals. By taking the time to learn about electrical safety, you can protect yourself and others from electrical hazards. Remember to always prioritize safety when working with electrical systems. A properly sized neutral conductor is a critical component of a safe and reliable electrical service. Always ensure that the neutral conductor is capable of carrying the maximum unbalanced load. The maximum unbalanced load is the greatest difference between the current on any one-phase conductor and the neutral conductor. In many residential services, the loads are relatively balanced. However, it is still important to size the neutral conductor appropriately to account for potential imbalances. Some appliances, such as electric stoves and dryers, can create significant unbalanced loads. These appliances typically use 240 volts for heating elements and 120 volts for other components, such as lights and controls. The 120 volt loads are connected between one phase and the neutral, creating an unbalanced load. In commercial and industrial settings, unbalanced loads are more common due to the presence of three-phase equipment and varying usage patterns. It is essential to carefully calculate the unbalanced load in these settings to ensure that the neutral conductor is properly sized. When calculating the unbalanced load, it is important to consider all connected loads, including lighting, receptacles, and equipment. Use the nameplate ratings of appliances and equipment to determine their current draw. For lighting circuits, use the wattage of the lamps to calculate the current draw. The NEC provides tables and guidelines for calculating the load of various types of equipment. Refer to these resources for accurate load calculations. After calculating the load on each phase, determine the maximum unbalanced load by subtracting the smallest phase current from the largest phase current. The result is the minimum current carrying capacity required for the neutral conductor. It is always a good idea to add a safety factor to the calculated neutral current to account for potential future load additions or unexpected imbalances. A safety factor of 25% is typically recommended. Multiply the calculated neutral current by 1.25 to determine the minimum allowable ampacity of the neutral conductor. Select a conductor size that has an ampacity equal to or greater than the calculated value. The ampacity of a conductor is the maximum amount of current it can safely carry without overheating. The NEC provides tables that list the ampacities of various conductor sizes and types. When selecting a conductor size, consider the type of insulation, the ambient temperature, and the number of conductors in a raceway or cable. These factors can affect the ampacity of the conductor. If the conductors are installed in a hot environment or bundled together with other conductors, their ampacity may need to be derated. Derating factors are provided in the NEC. Consult these factors to determine the appropriate derating for your specific installation. In addition to ampacity, it is also important to consider the voltage drop of the conductors. Voltage drop is the decrease in voltage along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC provides guidelines for limiting voltage drop. As a general rule, the voltage drop should not exceed 3% for branch circuits or 5% for feeders. Use voltage drop calculators to determine the voltage drop of the conductors in your installation. If the voltage drop is excessive, you may need to increase the conductor size or shorten the length of the circuit. Proper neutral sizing is critical for the safe and reliable operation of electrical systems. By following the guidelines in the NEC and considering all relevant factors, you can ensure that the neutral conductor is adequately sized to handle the maximum unbalanced load. Consulting with a qualified electrician is always a good idea if you're unsure about any aspect of electrical wiring. Always prioritize safety and follow all applicable codes and regulations. Firstly, calculate the total load connected to the service. This includes all lighting, receptacles, appliances, and equipment. Use the nameplate ratings of appliances and equipment to determine their power consumption. Secondly, determine the unbalanced load. This is the maximum amount of current that the neutral conductor is expected to carry. It is calculated by subtracting the smallest phase current from the largest phase current. Thirdly, select a neutral conductor size that is adequate for the calculated unbalanced load. The neutral conductor must have an ampacity equal to or greater than the calculated unbalanced load. Fourthly, consider voltage drop. Voltage drop is the decrease in voltage along the length of a conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. Fifthly, install the neutral conductor in accordance with the NEC and all applicable local codes. The neutral conductor must be properly grounded and bonded to ensure safety. Remember to always prioritize safety when working with electrical systems. If you are not comfortable working with electricity, hire a qualified electrician. The neutral conductor plays a vital role in electrical systems. It provides a return path for current and helps to maintain a stable voltage. Proper neutral sizing is essential for the safe and reliable operation of electrical systems. One of the key functions of the neutral conductor is to carry unbalanced current. In a balanced three-phase system, the current in each phase is equal, and the neutral conductor carries little or no current. However, in most real-world electrical systems, the loads are not perfectly balanced. This means that the current in each phase is different, and the neutral conductor must carry the difference. The neutral conductor also helps to maintain a stable voltage. When the loads are balanced, the voltage in each phase is equal. However, when the loads are unbalanced, the voltage in each phase can fluctuate. The neutral conductor helps to stabilize the voltage by providing a return path for current. In addition to carrying unbalanced current and stabilizing voltage, the neutral conductor also provides a path for fault current. If a fault occurs in the electrical system, the fault current will flow back to the source through the neutral conductor. This fault current will trip a circuit breaker or fuse, which will interrupt the flow of electricity and prevent further damage. The neutral conductor must be properly grounded to ensure that it can safely carry fault current. Grounding means connecting the neutral conductor to the earth. This provides a low impedance path for fault current to flow back to the source. The NEC requires that the neutral conductor be grounded at the service entrance. The grounding electrode must be a metal underground water pipe, a ground drain, or another approved grounding electrode. The grounding conductor must be sized according to the NEC. Bonding is another important aspect of neutral conductor safety. Bonding means connecting all metallic parts of the electrical system together. This includes metal conduits, metal enclosures, and metal equipment. Bonding creates a low impedance path for fault current to flow back to the source. The bonding conductors must be sized according to the NEC. Improper neutral sizing can lead to a number of problems. If the neutral conductor is too small, it can overheat and cause a fire. If the neutral conductor is not properly grounded, it can create a shock hazard. If the neutral conductor is not properly bonded, it can prevent fault current from flowing back to the source, which can also create a shock hazard. Always consult with a qualified electrician when working with electrical systems. Electrical work can be dangerous, and it is important to take all necessary precautions to prevent injury or death.